Here is the mixture problem, and we are going to solve it using three methods. First is by using separable variable. Second is utilizing integrating factor. Third is using Picard's iteration method. And lastly, we are going to solve it using MATLAB. Our problem states that a tank initially contains 100 gallons of fresh water. A mixture containing a concentration of 1 pound per gallon of salt enters the tank at a rate of 2 gallons per minute, and the well-stirred mixture leaves at the same rate. Find the amount of salt at any time t, and find the value of the salt after 10 minutes. Given on the board is the illustration of the problem. We have a Q of 0 is equal to 0 since the liquid used is fresh water, meaning that no concentration is present in the liquid. Next is dV equals 100 gallons since the volume is 100 gallons. Next is the concentration that enters the tank is 1/2 pound per gallon, and the rate is 2 gallons per minute, and the Q sub O is 2 gallons per minute. To easily identify these variables, note that your C must be mass over volume, while your Q must be volume over time.
So the first method to be used is separable by variable. By given equation for mixing problem is dq where dt equals ci qi minus co qo. So in this problem, all parameters are given except co. So by solving co is co equals q over vt, and vt is equal to vi plus q sub 1 minus q sub o times time. So input the parameters in this formula, you need to get q over t 1/2 times 2 minus co is vi, and qi minus q. So in this problem is the rate is same. In this problem the rate is same, so you can cancel this equal to 0. So the vi is 100 times the qo is 2, and simplify this, you get qi over 3 1 and cancel this, so you get 50 q over 50, and simplify more, minus q over 50. So by observation you can separate the variable, and observation you can separate the variable, so you can get transpose this into this, so dq over 50 minus q equal dt over 50. After that you can integrate both sides, you get ln, the u is 50 minus q, and this is equals t over 50 plus c. To get the q, you can introduce exponential, so if exponential both sides, so you can cancel ln. So get the q, so the value of q is q equals 50 plus c. By giving the initial value of q sub 0 equals 0, so you substitute this, and the value of q is qt equals to 0. So substitute the value of t and q, so we get 0, 50 So anything value raised to 0 is equals to 1. So you can get the solution is C equals -50. So by giving this problem, by giving find the value of salt after 10 minutes. So the time is equals to 10. So substitute and you can get the 9.06. You can get the concentration of salt after 10 minutes.
So for the second method, we will be using integrating factor. So as discussed a while ago, these are the given. So we all know that the general equation for mixing problem is equal to dq over dt is equal to C1 Q1 minus CO Q. So by substituting each value, will be given dq over dt is equal to 1/2 multiplied by 2 minus C sub O. Since we are not given C sub O, we all know that the formula of C sub O is equal to Q over total volume plus the difference between Q sub 1 and Q sub O multiplied to T. Multiplied to Q sub O, which is equal to 2. Then by cancelling 2 and 2, will be given 1 minus Q over total volume, which is equal to 100 gallons, plus the difference between Q1 and QO, which is just equal to 0. So we'll just cancel this out. Then multiply to 2. Then by simplifying, we'll be given dt over dt is equal to Q over 50. So as you can see, we can derive this to form a standard equation of linear ODE. So dq over dt plus q over 50 is equal to 1. So we get the mu of t, which is equal to e raised to the p of t. So the p of t in this case is 1 over 50. So 1 over 50t dt. So by simplifying, we will be given 1 over 50t. So yeah. So the solution for a linear ODE is equal to, in this case, we'll be using the letter of q, which is q of t is equal to the integral of mu of t multiplied to q of t dt plus c all over mu of t. So substitute each values, we will be given q of t is equal to mu of t, which is equal to e raised to 1 over 50t multiplied to q of t. So the q of t in this case is equal to 1, so we'll just negate it. dt plus c all over e raised to 1 over 50t. So simplify the integral, we'll be given q of t is equal to 50 multiplied to e raised to 1 over 50t plus c all over e raised to 1 over 50t. Then we'll just bring up e raised to 1 over 50. So we'll be given the equation q of t is equal to 50 plus c e raised to 1 over negative 50t. So since we are given an initial condition of q sub O is equal to 0, we'll just substitute each value. So q sub O is equal to 0. So 0 is equal to 50 plus c e raised to 1 over 50 multiplied to 0. We all know that any number raised to 0, it will be just equal to 1, so we'll just cancel this out. So the value of c will be equal to negative 50. So substitute this to the equation that we've got here. So q of t is equal to 50 minus 50 e raised to negative 1 over 50t. So in the problem, we are asked to find the amount of salt after 10 minutes. So we'll just substitute the value of t to 10. So q of 10 is equal to 50 minus 50 e raised to negative 150 multiplied to 10. So the given value will be equal to approximately 9.063 lb. That's all. 3, 2, 1, go.
I'm going to show you how to solve this problem using the third method or DP cards. I'm going to continue what they have already showed you, and they have said a while ago that the formula for this one is dq over dt. As for the dq over dt, we're going to multiply C1 by Q1 minus C2 QO. We all have this given variables except for the CO. To compute for the CO, we have Q over VT. So, substituting this value, 1/2 times 2 minus CO times 2. To get the CO, we have Q over the volume initial, which is 100, plus 2 minus 2 times T. Since this is 0, we are just going to cancel this one. We have Q over 100. I'm just going to erase this one and change it by Q over 100. Simplifying, we will have 1 minus Q over 50. This equation is the one that we are going to use in the iteration method. So proceeding, for the iteration method, we are going to have the first equation, which is phi sub 1, which is equal to the given equation a while ago, the 1 minus q over 50 bs. And we are going to evaluate it from 0 to any given time t. Since our initial condition is q of 0 is equal to 0, we are going to cancel this one, since it will be just 0. Proceeding, we will evaluate 1 bs from 0 to t. Integrating, we will have s from 0 to t. Therefore, for phi sub 1, we are going to have t. And then we are going to proceed by getting the phi sub 2. Phi sub 2. To proceed in getting the phi sub 2, we are going to substitute the given answer here, t, to q. Therefore, we are going to have 1 minus t over 50 ds. Since this is ds, we are going to use s instead, because the function will be in terms of s or q sub s. And then we are going to evaluate this from 0 to t. Therefore, we are going to have this one is s minus s squared over 50 times 2, or this will become 100. Evaluated from 0 to t. Therefore, we will have t minus t squared over 100. In phi sub 2, we can already simplify the
3, 2, 1, go.
We already have the phi sub 1 and phi sub 2. To have a more precise answer, we could still solve for phi sub 3. Proceeding, we will have phi sub 3 is equal to 1 minus, we are going to substitute this one to q. So we will have s over 50 minus s squared over 100 times 50, which is 5,000. And then we are going to evaluate this from 0 to t. Integrating, we will have s minus s squared over 50 times 2, which is 100, minus s cubed. I'm sorry, this should be plus. S cubed over 5,000 times 3, which is 15,000. Evaluated from from 0 to t. T squared over 100 minus t cubed over 15,000. Plus again. To show you what I'm saying a while ago, we will substitute the given minute, which is 10, to get the concentration. From here, the concentration is 10. A while ago, we have a concentration which is
3, 2, 1, go.
in the problem, we are asked to find the value of salt after 10 minutes. So we could simply substitute 10 minutes to the t here. So this one, it is evident that it should be 10. And this one is 10 minus 10 squared over 100. The answer is 9. A while ago, we are given the equation 50 minus 50 times e raised to negative t over 50. And substituting 10, we will have 9.063462. That is the value of salt. So we could see that as the phi sub n increases, the value gets closer to the given answer. Let's see what will be the value in phi sub 3. So 10 minus 10 squared over 100 plus 10 cubed over 15,000. And the answer is 9.06667, which is closer to this one compared to this one, which is simply just 9, and more so with this one, which is 10, which is somehow far from this answer. To have a more precise answer, I'm going to show you the phi sub 4. In phi sub 4, we are going to have the equation t minus t squared over 100 plus t cubed over 15,000 minus t raised to 4 all over 3 million. I already solved the equation, so if you want to know how I got this one, you should just substitute this equation to the q. So we will substitute 10 this time. 10 minus 10 squared over 100 plus 10 cubed over 15,000 minus 10 raised to 4 over 3 million. And the answer is 9.06333. As you can see, this one is still closer to this one compared to these last two answers, which is 9 and 9.06667. So therefore, our answer adheres to the theory, which is that as the n increases, the answer gets closer to the original answer.
So for sample problem 1, a tank originally contains 100 gallons of fresh water. A mixture containing a concentration of 1/2 pounds per gallon of salt enters a tank at a rate of 2 gallons per minute, and the well-stirred mixtures leave at the same rate. Find the amount of salt at any time t, and find the value of salt after 10 minutes have passed. So to solve this problem using MATLAB, the sample problem 1, you need to enter the following codes, which is SYMS, Q of T. So this will enter the values for Q of T, which is the amount of salt at time T. After pressing enter, the values will appear in the workspace at the right side, and the next step is to enter the initial conditions, which is Q sub 0 is equals to 0. So after setting the initial conditions, you need to enter the formula to solve the problem. Solve This is the solution to the differential equation. And the flow rate is 2 gallons per minute. So you can see the answer is 50 minus 50 raised to negative t over 50. So solving for Q of 10, need to enter the following codes. For the amount of salt in the tank after 10 minutes. So the answer is 50 minus 50 raised to negative 1 over 5. So for the answer, it is 50 minus 50 e raised to negative 1 over 5, or 9.063, approximately 9.063 using calculator.